Welcome to our in-depth analysis of a successful simulation demonstrating Picus Attack Path Validation capabilities. In this video, I will take you through each step of the simulation, highlighting key actions and decisions that led to achieving the simulation objective. You'll gain insights into the methods and strategies used by attackers and how Picus APV replicates these activities without causing harm. Let's dive in and explore the detailed attack simulation that unveils the attack paths likely to be exploited by attackers. This page contains basic information about the simulation. Here you can find details such as the target, the stager used, and the target domain. Additionally, by clicking on the cards here, you can see the list of actions used in the simulation. The Activity Feed section lists the actions that APV has taken. Each action can be examined as a separate card, and the cards display information such as the time the action was executed, the computer on which it was run, and the data obtained. The card list is sorted by date and the first action is listed at the bottom. Usually, when attackers gain access to a system, they'd first gather information about the compromised environment. Similarly, APV performs information gathering steps initially. The advanced decision engine then decides on the course of action based on the information gathered. For example, APV has elevated the process integrity by executing the UAC bypass action. By clicking on the card, you can reach the related node on the map on the right side. Looking at the node, you can see that a new process has been started by connecting with the integrity change label. To view all these labels, you can review the How to Read the Map section at the bottom of the page. Here you can see how nodes, processes, and paths are represented, as well as related integrity levels and path labels. Hovering over the node provides more detailed information about the newly started process. This section is just a small part of the map. If we zoom out a bit, you can see the path to the target and the critical actions along this path. By following this path, you can see actions and computers that were executed. This way, the path to the target can be fully seen and examined in detail. Just as you can view the node by clicking on the list, you can also click on any node along the path to access the related card and obtain more detailed information. For example, if you want to examine what happened at this exact moment in the simulation, you can click on the node and see that a pass the hash attempt was made via SMB. Besides the details, we can also review the summary of this path created in the simulation and see the breaking points of the simulation. To do this, I will switch to the Attack Path tab at the top of the page. The Attack Path tab displays the summary of the simulation and the breaking points. On the left-hand side, APV lists the actions taken with their details. On the right-hand side, APV shows the computers compromised in the attack path. You can also see the statistics about the objects used while APV progresses towards the target. In this example, APV used one host and 2 servers. If you examine the attack path, you will see that APV started its attack simulation using the workstation 06 and laterally moved to servers 12 and 08, respectively. Under the Actions section, the first card describes the information gathering step that involves Active Directory enumeration. The card also displays the number of servers, computers, and users involved in this action. When clicked, the card provides important details such as which computer the action was executed on, the integrity level, and which user the action was executed by. The second card shows that the integrity was elevated by performing a UAC bypass. A closer look tells us that this action was executed on the workstation 06 with the Nola Linden user. The label below also indicates the integrity change. The next card shows that new user information was gathered to take over other computers and spread in the system. You can see that 2 users' NT hash values were obtained by performing LSAS credential dumping. Using the newly acquired credentials, APV switches to the SATA RISA user. In the fourth card, APV reads the lapsed password using the SATA RISA user and obtains server 12's local administrator credentials. Then, APV moves laterally to server 12 via SMB using the admin credentials. The label below indicates the access to a new machine. Now that APV has gained access to server 12 with system rights, it performs credential dumping actions and acquires the hash credential for the SRV admin user. Using this credential, APV launches a pass the hash attack over SMB to server 08 and successfully gains access to server 08 with system rights. The last card shows that APV used the LSAS credential dumping technique and was able to compromise the domain admin user completing the simulation objective. Thank you for joining us on this detailed walkthrough of an example attack simulation with Picus Attack Path Validation. We hope this video has provided valuable insights into how attack path validation can effectively replicate real-world attack scenarios without harming your production environment. Stay safe and secure, and I will see you in the next video.